Next transformation is the reflection or the mirror. By using the reflection routine, it is possible to obtain the mirror image of any object. It is necessary that a reflection should be always obtained with axis of reflection. So axis of reflection we have to define. Axis of reflection can be x-axis, can be y-axis, or a axis parallel to x-axis, or a axis parallel to y-axis, or any line or axis which is inclined to x and y axis. So there are number of cases that we want to discuss in the case of reflection. Suppose we have the axis of reflection is x-axis, then the x-coordinate of the point will remain same while the y-coordinate will flip. Similarly, when the x-axis reflection is y-axis, then the y-coordinate of the point will remain same while the x-coordinate will flip. So consider here a point P which has a coordinate of x, y, and we want to take the mirror image above the x-axis. So when the axis of reflection is x-axis, you have to take the mirror image of the point P about x-axis, then whatever the distance here y, same distance will repeat here also. But for this one, x coordinate will not change. You will get here P prime, which has the x coordinate is same as equal to x, and the y coordinate will become minus y. So we have x prime will be same as equal to x, y prime will be same as equal to minus y. If you take a reflection about the of x-axis, we can write this reflection matrix as P prime is equal to P into the reflection matrix. So we'll use the M, which one is mirror. We have P prime is same as x prime, y prime. The coordinate of P is x, y. Now we want to generate here x prime is equal to x. So we have x1, contribution of y is 0, and we want to generate here the y prime is equal to minus y. So contribution of x is 0 and y contribution is minus 1. So this one is our mirror about the x-axis. Consider the second case here. We have a axis of reflection is y-axis. So this y-axis is axis of reflection. And let's consider here we have point P, which has a coordinate of x, y. So since the axis of reflection is y, you will get a mirror image of P. But distance is always positive value, so this distance is x as well as this distance is also equal to x. So coordinate of P prime will be equal to minus x, y. So we have x prime will be equal to minus of x, y prime will not change, y coordinate will not change, will be same as equal to y. So we have P prime is equal to P, the mirror matrix about y. So in this case we have P prime is x prime, y prime is equal to x, y. Now see the definition of mirror matrix. X prime become minus x, so x is to be multiplied by minus 1. Y contribution is 0, so y value will be equal to 0. Y prime is not changed, so x contribution is 0, and we have y prime is same as y, so you have to make it equal to 1. So this one is the mirror matrix about y when the reflection is taking place about the y-axis. So consider here now the reflection of a line which is parallel to x-axis. So we'll represent here x-axis, we'll represent here y-axis, we'll represent here the point P, x, y. So the vertical distance above the x will be equal to y unit. And we have to show here one reflection line which is parallel to x-axis. So let's consider here we have reflection line. Suppose we have reflection line is given as y is equal to b. So all the y coordinate of this point will be equal to b. So from reflection line, this point at a distance equal to y minus b. So point P from reflection line at a distance equal to y minus b. And when you do the reflection of point P about the given reflection line y is equal to B. So the reflection of the point P about y is equal to B is represented by P prime having coordinate equal to x prime and y prime. Since the reflection is taking place about, so this vertical distance is also equal to y minus b. So the distance above and distance below the reflection line is always remain same. So this distance is same as y minus b, and this distance is same as equal to y prime. Now y prime will be equal to y minus 2 times of y minus b. So in this case we have x prime will not change. X prime is still equal to x, but we have y prime is equal to total distance is y minus this vertical distance will be equal to 2 times of y minus b. That is we have y minus 2 times of y plus 2 times of b, or we have minus y plus 2 times of b. So minus y term is same as equal to the first term here, and 2b is a translation here. So in this case we have to use the homogeneous system. We have p prime is equal to p multiplied by the reflection matrix or mirror matrix. P prime is same as x prime, y prime, 1. This one is homogeneous coordinate system, and we have p is equal to x, y, 1 multiplied by x prime. We are interested same as equal to x, so you have to write this value as 1 0 0. Then y prime you have to write as minus y plus 2 times of b. So we have x term is not present, so it should be equal to 0. Then y term should be equal to minus y, then you have to write here minus 1 and plus 1 into 2b. And finally we want here the 1, so we have 0 into x is 0, 0 into y is 0, and finally we have 1. So this one is a mirror matrix when the axis of reflection is parallel to x-axis. Same story you can continue if we have a reflection line is parallel to y-axis. Now we'll discuss here cases in which the axis is inclined to x-axis. So when we take the reflection of point about a line which is parallel to x-axis and has a equation y is equal to b, in that case we have x prime is equal to x, y prime is equal to minus y plus 2b. In that case we have a mirror matrix is 1 0 0 because x coordinate is not changed. Then we have 0 minus 1 0, y coordinate become minus y, and then we have additional translation that is equal to tx equal to 0, ty is equal to 2b. Now what is the result we have obtained for a reflection of a line which is parallel to x-axis has an equation of y is equal to b can be obtained using the 3 different steps. First, you have to translate the given line on the x-axis. Now this equation of a line is y is equal to b. So for translation of this reflection line on x-axis, we need to shift the line by b units in a downward direction. Therefore we have ty is equal to minus b and tx equal to 0. So this point will shift in a downward direction with no change in the x direction because tx equal to 0, but y coordinate will be changed as y plus ty, that equal to y minus b. And we have translation matrix is 1 0 0 0 1 0 tx ty 1. So tx value you have to put as 0, ty value you have to put as minus b. The translation matrix is 1 0 0 0 1 0 0 minus b 1. After you do the translation, and we have a new translation line is y is equal to 0, so you can take the reflection of the given point p1 about the x-axis. So step number 2 is to take the reflection about the x-axis, then x prime will be same as equal to x, y prime is equal to minus of y. So we'll get the point P2 which has x coordinate will remain same and the y coordinate become negative, that is minus of y minus b. So the mirror matrix we can write in the homogeneous system as x prime is same as equal to x, that equal to 1. y prime become minus y, that equal to minus 1, rest coordinate will be equal to 0, and finally because of homogeneous system we have 1 and 0 0. After you take the reflection about the x-axis, we have to shift the given translation line back to the original position. That is, you have to invert the translation by tx equal to 0 and ty is equal to plus b. So we have to invert the translation by tx equal to 0 and ty is equal to b, and we have to write here one more translation matrix. So the second translation matrix is T2, and we have tx equal to 0, ty is equal to b. So we have 1, 0, 0, same copy. Then we have 0, 1, 0, tx is 0, ty is equal to b, and then we have 1. So total transformation matrix here is T1 multiplied by mirror matrix M multiplied by translation matrix T2. We want to solve here the total transformation matrix as T1 into M into T2. So we have total transformation matrix. T1 you have to write as first translation, mirror as this matrix, and translation second matrix you have to write down this matrix. So we have just substituted here the translation matrix as 1 0 0 0 1 0 0 minus b 1. Mirror matrix is 1 0 0 0 minus 1 0 0 0 1, and the invert translation matrix is 1 0 0 0 1 0 0 b 1. You have to carry out the product here, so first translation matrix will be as it is, and here we carry out the product of second matrix and third matrix. So we have first row and first column. 1 into 1 is 1, 0 and 0. So this will be same as equal to 1. Then we have first row and second column. 1 into 0 is 0, 0 into 1 is 0, 0 into b is 0. Then we have first row and third column. 1 into 0 is 0, 0 into 0 is 0, 0 into 1 is 0. Then we have second row, first column. 0 into 1 is 0, minus 1 into 0 is 0, 0 into 0 is 0. Then we have second row, second column. 0 into 0 is 0, minus 1 into 1 is minus 1, 0 into b is 0. Then we have second row, third column. 0 into 0 is 0, minus 1 into 0 is 0, 0 into 1 is 0. Then we have third row and first column. 0 into 1 is 0, 0 into 0 is 0, 1 into 0 is 0. Then we have third row and second column. 0 into 0 is 0, 0 into 1 is 0, 1 into b is b. Then we have third row and third column. So we have 0 into 0, 0 into 0, and 1 into 1 is 1. So we left here 1 0 0, 0 minus 1 0, 0 b 1, and now we'll find out here the total transformation matrix. So again start here with the first row and first column. 1 into 1 is 1, plus 0 plus 0, so it is equal to 1. Then we have 1 into 0 0, 0 into minus 1 is 0, 0 into b is 0. Then we have first row, third column. 1 into 0 0, plus 0 into 0 is 0, plus 0 into 1 is 0. Then we have second row and first column. 0 into 1 is 0, plus 1 into 0 is 0, 0 into 0 is 0. Then we have second row and second column. We have 0 into 0 is 0, 1 into minus 1 is minus 1, plus 0 into b is same as minus 1. Then we have 0 into 0, 1 into 0, 0 into 1 is equal to 0. Finally, we have third row, first column. 0 into 1 is 0, minus b into 0 is 0, 1 into 0 is 0. Third row and second column. 0 into 0 is 0, minus b into minus 1 is plus b, 1 into b, so that is additionally plus b, and finally we have 0, 0 and 1. So this term is always unity. Final transformation matrix as 1, 0, 0, 0, minus 1, 2 times of B, 0, 0 and 1. This result is same as the result that we obtained in the first case, that is 1, 0, 0, 0 minus 1, 0, 0 to be 1. So if you do the translation, that is shift the line to the x-axis, then take reflection about the x-axis and then invert the translation, your result is same. So both way you can solve the problem by taking the 3 step, or you remember directly the given mirror matrix. I think these steps is more straightforward and it will take a time, but you don't have to remember number of things. Only the basic translation, basic mirror matrix you have to remember. Now we'll discuss here the reflection about a line which has the equation y is equal to x. It means that the slope will be equal to 1. That is, the line will make an angle equal to 45 with respect to x and y axis both. So let we have x axis, y axis. So we have a reflection line which has the equation is y is equal to x. And we want to develop here the mirror matrix, that is a reflection matrix. So we'll consider here a point P which has the x coordinate equal to x, y coordinate equal to y. So we have point P is x comma y, and I want to reflect this point about the given reflection line y is equal to x. So its mirror image will come on this side. So the mirror image will be exactly perpendicular to the reflection line here, will be at this point, and this point will become P prime, which has a x coordinate equal to x prime and y coordinate equal to y prime. So this distance and this distance is same distance. So whenever we have a reflection line, as the equation says y is equal to x or x is equal to y, it means that the x coordinate will become the y coordinate and the y coordinate will become the x coordinate. So this distance which is measured from origin is x prime, and this distance is same as equal to y prime. So reflection about a line y is equal to x, our observation is that the coordinates are just interchange. That is, x prime will be original coordinate equal to y and y prime original coordinate equal to x. So in this case we can write the mirror matrix as P prime is equal to P multiplied by mirror matrix M. P prime is same as equal to x prime, y prime. P matrix is original coordinate is x, y. Since here x prime is equal to y, so you have to adjust the first column as x into 0 will be 0, y multiplied by 1. So we have x prime is same as 0 plus y is equal to first term. Second column we can write for y prime, which is equal to x. So you have to write this value is equal to 1 and this value is equal to 0. Our result is x plus 0y, that is same as this matrix. So this one is a matrix when we have y is equal to x. Now consider here a second situation in which we want to take the reflection about a line which has y is equal to minus x. So this slope is negative, and this one is a reflection line which has slope is equal to minus 1, and we have equation is y is equal to minus x. So if you have any point P here which has originally a coordinate is x comma y, so you will get here new point equal to P prime which has a coordinate equal to x prime, y prime. According to the equation y is equal to minus x, it means that we have x prime will be equal to minus of y, and we have y prime is equal to minus of x. That is the only change. So instead of 0 1 it will be minus 1, 1 0 it will be minus 1. That will be the mirror matrix when we have reflection is taking place about y is equal to minus x. So x prime will be equal to x multiplied by 0, that is 0, y multiplied by minus 1 is x prime is equal to minus y, and y prime is equal to x into minus 1 is minus x plus y into 0 is 0, that is minus x. So this one is a mirror matrix when we are taking the reflection about y is equal to minus x, and 0 1 1 0 is a reflection taking place about y is equal to x. When we are taking the reflection about the x-axis, in that case the x coordinate will not change, y coordinate become minus 1. So x coordinate position you have to remember as first position, and this corner position is y position. So x will remain same, so you have to write down 1. Y prime become minus y, that equal to minus 1. And when you take a reflection about the y-axis, y coordinate will remain same, x coordinate will change. So we have x prime is equal to minus x, y prime is equal to y. So position of x you have to write as minus 1, position of y you have to write as 1. And if you have a reflection of a line parallel to x-axis, so first you translate the line on the x-axis, take mirror image and retranslate. Or finally you can get the equation as 1 0 0 0 minus 1 0 0 to be 1. So if the position of x is 1 and the position of y is minus 1, means you are taking the mirror image about the x-axis, which has the equation of line is y is equal to 0. If the position of x is minus 1 and the position of y is not changed, that is equal to 1, it means that you are taking the reflection about the y-axis, that is x is equal to 0. And if you take a reflection about the line y is equal to x, then x and y coordinate will interchange. So x prime will become y, y prime will become x. So x multiplied by 0, y multiplied by 1, so x prime will be same as equal to y. X multiplied by 1 plus y multiplied by 0, so y prime is equal to x. It is 0 1 1 0, and if you have a reflection of a line about y is equal to minus x, just remember this and make minus 1 minus 1. So this one is a little idea about the mirror matrix or reflection. You can develop the reflection about any line. I have taken here a standard case, that is y is equal to x. In general we have y is equal to mx plus c, where m represents the slope, c represents the y-intercept. Right now we have y-intercept is equal to 0 because line is passing through the origin, and we have slope value is equal to 1. In this case we have value of m is equal to minus 1 and the y-intercept equal to 0 when we have equation of line is y is equal to minus x. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.